again to this video segment. In this video segment, we shall be talking about implicit differentiation, or you can say implicit differential calculus. Now, before you understand or before you view this video, please go back and view the videos on the usual differentiation, which we call explicit differentiation. You need to view those videos. You also need to view the videos on the rules of differentiation, like the power rule, the sum rule, product rule, quotient rule, and chain rule. Yeah, you need to know those 5 rules also. Then you also need to know the differentiation of some functions like the exponential function and the rest of them. So please, you need to know those rules. So if you can go back and view those videos before you view this one, that would facilitate your understanding. What do we mean by implicit differentiation? Let me give you an example. If we have something like y equal to x plus 5, and then you have something again like x plus y equal to 5. Look at these two functions. In the first function, we see that y is expressed in terms of x. We say that y is expressed explicitly, is expressed in terms of x, like y equal to. But here, you see that y and x are implicit. They are implicit. So we will just call this an explicit function. Explicit function. Because y is a function of x. Here you see y is a function of x. In this case, it is a linear function of x. But in this case, x and y are expressed implicitly. So in this case, we say it is an implicit function. Implicit function. So implicit differentiation means differentiation of implicit functions. That is what we are going to talk about. All right. And in implicit differentiation, we have to differentiate each term with respect to x. So you need to know the rules of differentiation, those rules. So when you're differentiating the x, it's not a problem. But now when you differentiate y, this is what you have to know extra. Right? What do you have to know extra? If you differentiate y with respect to x, WRT means with respect to. Please go back to the previous videos on differentiation, and before you view this, like I said earlier, okay, this means dy dx, or you can say y prime, or you can say f prime of x, or f prime of x. If you differentiate y squared with respect to x, right, this gives you 2y dy dx, or 2y prime. Now, in this lesson, I would like to be using y prime. Sometimes I will use the y dx, but most of the time I would like to use y prime. If you differentiate y cubed with respect to x, what do you think it will give us? It will give us 3y squared y prime. Remember I said y prime means the y dx. So that is the way it goes. So the only difference is that when you differentiate a function of x with respect to x, it gives you the terms in x. But when you differentiate a function of y with respect to x, you still have the term and also you have the y dx. That is what you should know in this implicit differentiation. we just do the rest as it is. Now let's look at some examples. Example 1. If we have, you have s6y plus y6x equal to 9. It says differentiate with respect to x. So if you have this is implicit differentiation. So y is not expressed explicitly in terms of x. So this is implicit differentiation. We do it like we do the normal differentiation, but we have to keep in mind this note. Now if you look at this, s6 times y, for instance, let me just do this one at a time. x6 times y. If you want to differentiate this term, remember the product rule. Refer to the previous video about the product rule. If you want to differentiate this, to keep s6 constant, and you differentiate y. If you differentiate y, it gives you y prime or the y dx, plus you keep y constant, and you differentiate x6, it gives you 6x5. So that is what it will give you for this one. Now if you have y6x, if you keep y6 constant, you differentiate x, gives you 1, plus you keep x constant, you differentiate y to the power of 6, it gives you 6y5 y prime, the y dx. You have to be careful in this. So that is how you do it. So I just wanted to illustrate it. Let's now, and then if you differentiate a constant, it gives you 0. So you keep x is constant, differentiate y, gives you the y dx, which is y prime, plus you keep y6, plus you keep y constant, differentiate x6, it gives you 6x5. That's for this. Then plus, here you keep y6 constant, differentiate x, it gives you 1, plus you keep x constant, differentiate y6, it gives you 6y5 y prime. And then this will be equal to, if you differentiate 9, it gives you 0. So this gives us x6 y prime plus 6x5 y plus y6 plus 6x y5 y prime equal to 0. Let us combine the like terms. The like terms in this case are those terms with y prime. And then we move the rest over to the other side. So this means x6y prime plus 6xy5 y prime equal to negative, when you move this it will be negative, 6x5y plus y6. Right? So you now find that y prime is similar in both cases. So bring out y prime. So this is y prime into s6 plus 6xy5 equal to negative 6x5y plus y6. And then you divide both sides by s6 plus 6xy5. So our y prime will now be negative 6x5y plus y6 all over s6 plus 6xy5. That's your question. And and that's the answer. And that is the answer. Okay? Now, what if you're asked to find the slope? What if you're asked to find the slope of the function s6y plus y6x equal to 9, you want to find it at -1, -1. Now, you know, when you talk about slope, I would like you to also view the videos on application of differentiation, which you have a lot of application of the differentiation. You also have the application in slopes, in maximum and minimum values, and the rest of them. So if you view the videos on that, you will see this kind of question. Now you see that if you have this kind of question, they are just asking you to find the y prime or the y dx at these points. That is what it means. So now the slope will be y prime at -1, -1. So that will now be what? The slope will now be -6 times -1 all to the power 5 times -1 plus -1 all to the power 6 all over -1 all to the power 6 plus 6 times -1 times -1 all to the power 5. Now this means that x is -1 and y is -1. It means that x is -1, y is -1. So wherever we see x, we put -1. Wherever we see y, we put -1. Alright, now, if you do recall, -1 to raised to power even number will give you 1. But -1 raised to power odd number will still give you -1. Let me explain. Because it will kind of waste time if I come and start writing -1 times -1 times -1 times -1 times -1. Okay. If you have -1 like raised to power 2, it gives you -1 times -1, which gives you 1. If you have -1 raised to power 3, it gives you -1 times -1 times -1, which gives you -1. If you have -1 to the power 4, it will still give you 1. So if you have -1 raised to power even exponent, it gives you 1. If you have -1 raised to power odd exponent, it gives you -1. So this is 6, this is negative. You have to be very careful here. Now this is 6 times -1 times -1 plus 1, because -1 to the power 6, 6 is an even number. So -1 raised to power 6 is 1. All over 1 plus 6 times -1 times -1. Right? And then this will give us negative in parentheses. This is 6 times 1, which is 6 plus 1 all over 1 plus 6. And that is -7 over 7, and that is -1 as your answer. Okay? Example 2. Example 2. Find y prime. 2y minus x plus xy equal to 6. In this example also, you have to differentiate each term with respect to x. And you also take note of that, of differentiating y with respect to x, which gives you y prime, or the y dx. So here, this is, you call this a product, 2 times y. Okay, so we use the product rule. You keep 2 constant, differentiate y with respect to x, it gives you y prime. Plus, you keep y constant, differentiate 2 with respect to x, it gives you 0. Anytime you see a product, try and use the product rule. Anytime you see a product. Then minus, if you differentiate x with respect to x, it gives you 1. Plus, xy is a product of x and y. Keep x constant, differentiate y, gives you y prime. plus, keep y constant, differentiate x, it gives you 1. Equal to, differentiate 6, it gives you 0. So this will be 2y prime plus, y times 0 is 0, minus 1 plus xy prime plus y equal to 0. So this is 2y prime minus 1 plus xy prime plus y equal to 0. So now you get the like terms. The like terms are those terms that have y prime. So this is 2y prime plus xy prime equal to negative, parenthesis, let me transfer, negative 1 over here is 1. Negative, I will just say negative 1 over here is 1, just put 1. Then plus y over here is minus y. You can write it this way, or you can also write it this way. Negative 1 plus y. You can write it this way. Yeah, but I'll just write negative 1 moves over here is 1, plus y moves over here is minus y. Right? So, y prime is common, right? You bring out y prime. 2 plus x equal to 1 minus y. And then you divide both sides by 2 plus x. When you divide both sides by 2 plus x, you see that y prime will give you 1 minus y over 2 plus x. And that is the answer. Welcome to the second part of this segment, implicit differentiation. We want to do more examples on the implicit differentiation so that you get a better understanding of it. So let's look at that is example 3 now. Two variable quantities. J and K. J and K are found to be related by the equation J cubed plus K cubed is equal to 91. What is the rate of change? What is the rate of change dj dt when j is 4 and dk dt is 1. Okay, now look at this problem. We want to find the j dt, and if you go back to the previous videos on application of differentiation, one of the applications of differentiation is to find the rate of change. So how do we find the j dt? We found that the j dt is equivalent to saying dj dk times dk dt. What rule do we call this again? If you can remember the rules of differentiation. We call this a function of a function rule. Function of a function rule. Or chain rule. Function of a function rule or chain rule. Because we can't find j directly in terms of t. So we have to find it as a function of a function. We have to find j as a function of k first. So that is why it's called function of a function rule. I talked about that in the previous videos as well. So we know the k dt. The k dt is 1. So let's find the j dk. Now we have j cubed plus k cubed to give us 91. We want to find the j dk. So what does it tell? What does this tell you? What variable do you think is the dependent variable? And what variable do you think is the independent variable? For instance, when you have, let's go back a little. When you have the y dx, that means y is a function of x. That's why you say the y dx. Y is a function of x. Y is the dependent variable. X is the independent variable. So if you have the j dk, you want to find the j dk. The j dk, that tells you that j is a function of k. That is what it tells you. So that j is the dependent variable and k is the independent variable. So if you want to give, now you remember when at the beginning of the first part of this implicit differentiation, when we were differentiating y with respect to x, it gives us the y dx. When we differentiate y squared with respect to x, it gives us 2y dy dx as 2y y prime. Okay, when we differentiate y cubed with respect to x, it gives us 3y squared dy dx. So if you differentiate j cubed now, because j is the dependent variable, you have to be careful about this. So it will not give you only 3j squared. No, j is the dependent variable. So it's going to give you 3j squared dj dk. Okay? Now plus k cubed, k is the independent variable. So this is 3k squared. And that will give you 0. So let's find the j dk. So this gives that 3j squared dj dk equal to negative 3k squared. We divide both sides by 3j squared. So we see that the j dk is equal to negative 3k squared over 3j squared. Right? So you cross out. So the j dk is equal to negative k squared over j squared. Alright. Now, we know that j is 4. We don't know what k is. So we have to find k. So we can complete this. Now the k dt is 1. But we have to find the j dk. So we can find the j dt. Of course, we know that j is 4. So let's find k. Okay? So I will just come here. Now, bet j cubed plus k cubed is 91. J is 4. So 4 cubed plus k cubed is 91. So k cubed is 91 minus 4 cubed. K cubed is 91 minus 4 cubed is what? 4 times 4, 16 times 4, 64. 64. So k cubed is equal to 91 minus 64 gives what? 11 minus 4 is 7. 8 minus 6 is 2. So this implies that k will now be what? K will be cube roots of 27. So k will be 3. K is 3. Right? So the j dk will now be, negative 3 squared all over 4 squared. Right? Now, you have to be careful of this. I want to illustrate something. Negative 3 squared and then negative 3 all squared. They don't give the same thing. Students kind of sometimes confuse these two to mean the same. They don't mean the same thing. This case will give you negative 3 times 3, which is negative 9. But in this case, negative 3 all squared will give you negative 3 times negative 3, which is 9. So be careful not to get confused here. So this will now give us negative 9/16. That is for the j decay. Right? Now let's find the t. Let's find the t. So I'm going to erase this. So therefore, the dt, of course, will give us the j decay times the k dt. Now, but we see that the k dt is 1. The j decay is negative 9/16. So this is negative 9/16 times 1, which is negative 9/16. And that's your answer. Example 4. Example 4. Differentiate. Find the slope of the curve. Find the slope of the curve x cubed minus x squared y squared equal to negative 9 at 3 and negative 2. So find the slope at the curve. Now, if you viewed earlier video segments about application of differentiation, you will find out that one of the application of differentiation is to find slopes of lines and curves. Okay, now so we have to first of all differentiate, and this is this is an implicit function. So we are going to use implicit differentiation because y is not expressed explicitly in terms of x. So this will give us 3x squared, of course, then minus, now x is the independent variable, y is the dependent. Now here you use product rule, right? Because x squared times y squared, that is product rule. So what we have to do, because of this negative, let's put a parenthesis here because we don't want to run into problems with negatives. So put a parenthesis there because of the negative. Now, in the earlier problems I did, if it's positive, you're good. But if it's negative, just put a parenthesis because a negative will automatically affect any positive or negative values. Yeah, but if you have a positive, you can just leave it like that because positive will not really affect it. Will not affect it, but negative will. So let's now consider x squared y squared. Product rule to differentiate it. So you keep x squared constant, differentiate y squared, it gives you 2y dy dx, which is y prime. Then plus, you keep y squared constant, differentiate x squared, it gives you 2x. Okay? And this will give us, you differentiate negative 9, it gives you 0. If you differentiate a constant, it gives you 0. So, this is now 3x squared minus, multiply this is 2x squared y prime plus 2xy squared equal to 0. So this will give us 3x squared minus, you now see that negative will affect it. So use distributive property, this is negative 1. It will affect it. 2x squared y prime minus 2xy squared equal to 0. Okay, we don't want to deal with negatives. Let's move this negative here that has y prime over here, and then we leave this as it is, right? So this is 3x squared minus 2xy squared equal to 2x squared y prime. Now, if you don't understand how I solve equations, please view the videos on equations, solving equations. View that video and you would understand what I mean. by transferring. You know, you move. That's the best. That's very good way of solving equations. So next thing, we can rearrange this because we want to find y prime. So because we want to find y prime, we want it to be on the left hand side. View the videos on equations. So this will give us 2x squared y prime equal to 3x squared minus 2x y squared. So you divide both sides by 2x squared y. So you have that y prime will be 3x squared minus 2x y squared all over 2x squared y. This is the derivative. This is the derivative with respect to x of the curve. Now let's find the slope of the curve at that point. So at 3 and negative 2, now this means that x is 3 and y is negative 2. So we now have that y prime will be 3 times 3 squared minus 2 times 3 times negative 2 all squared all over 2 times 3 squared times negative 2. What I did was, wherever I saw x, I put 3. Wherever I saw y, I put negative 2. So y prime will be equal to 3 times 9 minus 2 times 3 times. And negative 2 all squared will give us 4. I did an example like this in the other video. So all over 2 times 9 times negative 2. Okay, so y prime will now give us what? 3 times 9 is what? 27 minus 2 times 3 is 6 times 4 is 24 all over 2 times 9 is 18 times negative 2 gives us negative 36. So this gives us 3 over negative 36, and that is 1 over negative 12, which is negative 1 over 12 as the answer. Some people will ask, why don't I leave it this way? You can, but it is not proper. We usually write negatives on top. View my videos on multiplying and dividing fractions, and you will understand. Yeah, go back to the videos on multiplying and dividing fractions, and you will understand. Okay. Another question, maybe the last question before we go. Example 5. If find the derivative. Find the derivative xp over x plus p equal to 2. Now, if you look at this, some of you might be tempted. Oh, this is an implicit function, but some of you might be tempted to use the quotient rule. You know, just like we've been using the product rule, even on implicit functions, and it worked for us. Some people might be tempted to use the quotient rule. Please don't. Just try and clear any fractions, you know. Just try and clear any fractions, because if you run into the quotient rule, you might run into difficulties. So the best thing to do is try and clear the fraction, right? Because the xp over x plus p means 2 over 1. So you can use cross product, cross multiply, or use cross product. So this gives xp equal to 2 into x plus p. So this way is better. You can do it this way and it's easier. So this will give you xp equal to 2x plus 2p, distributive property. So we can now, in this question, what do you think is the dependent variable? Now they didn't use y again, they use p. So you want to find the p dx. So p is the dependent variable. And x, as usual, is the independent variable. So here you keep x constant, differentiate p, the p dx, plus keep p constant, differentiate x, 1, equal to differentiate 2x, 2, plus differentiate 2p, keep 2 constant, differentiate p, the p dx, plus keep p constant, differentiate 2, 0. So this is x, the p dx, plus p, equal to 2 plus 2 the p dx, plus 0. So let's get the like terms. The one that has the p dx. So this is x, the p dx, minus 2 the p dx, equal to 2 minus p. Right? So we can now, let me write it again, s the p dx minus 2 the p dx equal to 2 minus p. The p dx is common, bring it out. The p dx, you have x minus 2 equal to 2 minus p. So the p dx will give us 2 minus p over x minus 2, because you divide both sides by x minus 2. That's the answer. So, that's your answer. Now, let me just try again and do one more before I end this segment. Let me try again and do one more just to make sure I touch every aspect. Right? So, example 6. If you could pause the videos and you try it on your own, that would be fine. Differentiate implicitly. Differentiate implicitly. So let me just try and get all varieties of the question you can get. P plus 4 times x plus 3 equal to 48. Differentiate implicitly with respect to x. So, p plus 4 times x plus 3 equal to 48. I'm going to use two methods to do this. When you have a problem like this, I will use two methods to do it. First one, I will use a product rule. And the second one, I will just expand it and then use product rule as well. So, whichever one is easier, that's fine. Okay, so let me say first method, I'll just use product rule. First method, I'll just use product rule. Product rule and sum rule. And sum rule. That's what I'm going to use. Now in this case, you see x is still the independent variable and p is the dependent variable. Now, I will keep this constant and differentiate this. And then I'll keep this constant and differentiate this. So I keep p plus 4 constant and differentiate x plus 3. Differentiate x is 1. Right? Plus 3 is 0. Then plus, I'll keep x plus 3 constant. Differentiate p is the p dx. Differentiate 4 is 0. And then equal to 48. Differentiate 48 is 0. And this will give me p plus 4 times 1 plus x plus 3 times the p dx equal to 0. Okay, so p plus 4 times 1, of course, is p plus 4. P times 1 is p, plus 4 times 1 is 4. Then plus, I'll just write the p dx in front, so not to get you confused. So this is p plus 4 plus the p dx times, once I reach here, okay, I'll just move p plus 4 to the other side. So the p dx times x plus 3 will give us negative p plus 4. Put the parentheses. Or you say negative p, negative 4. Then you divide both sides by x plus 3. So the p dx will give you negative p plus 4 all over x plus 3. Okay, or second method, before I leave, second method, I will expand it first before I differentiate. I will expand, then differentiate, expansion, then differentiation, then differentiate. So expand is first. This is xp, or px. You can say px or xp. Doesn't matter. Right? Or let me say px because p comes before x. So px plus 3p plus 4x plus 12 equal to 48. You can use FOIL or just simple expansion. Now this is I now differentiate this, right? Differentiate, keep p constant, differentiate x, gives you 1, plus keep x constant, differentiate p, dp dx, plus, I'm done with this product rule. 3, keep 3 constant, differentiate p, dp dx, keep p constant, differentiate 3, 0, plus, differentiate 4x is 4, differentiate 12 is 0, differentiate 48 is 0. So this is p plus x dp dx plus 3 dp dx plus 0 plus 4 plus 0 equal to 0. Let me move all this. Let me move all things. Get the like terms together. So this is x dp dx plus 3 dp dx equal to negative p plus 4. I put parentheses, or you say negative p, negative 4. And then x plus 3, the p dx is common, so you bring it out, the p dx into x plus 3 equal to negative p plus 4. And then you can now divide both sides by x plus 3. You can now divide both sides by x plus 3, and you see that the p dx will be negative p plus 4 over x plus 3. Thank you for listening to this presentation. If you have further questions, please go to my website and ask your questions there. If you can also go to the video and make your comments on the video. I want to really thank you for your time. On the moment of conscience with Sam Dom, what I do every time I do a video, I would like to appreciate all my teachers so far. I would like to thank all my teachers so far that have taught me from the elementary level up to the graduate level. So, teachers, thank you, thank you, thank you. And finally, also, please try at this season, this Christmas season, I would like you to be generous to people, to help the poor in our midst. Remember those, the motherless babies, the orphans, those who don't have anything on their own, the foster children. Remember them in this season. Okay, thank you. Have a nice day.